So this is what a typical problem looks like for today. And we have to know a bunch of things that I reviewed, but you know, it's been a while since I was here. I was gone for a few days there. You have a sub, so let's just review this stuff. So when you have an equation like this, that's all factored out. You remember I said if you can factor it, you should. So it's all factored already. And that tells me that x equals -3 is an important number. Why? Because it makes the whole equation 0. If I put a -3 here, this will be 0. So it doesn't even matter what these are. The whole thing's got to be 0. And so that makes the y equal 0. That's the x-intercept is when y equals 0. The y-intercept is where x equals 0. And then if I multiplied this thing out, just imagine that I multiplied this thing out, then this would have an x times an x times an x, which makes an x to the third as its lead term. Then yes, there'd be a bunch of junk in the middle, which we don't care about. And then last, you remember how I said that the x-intercept would be where y equals 0, this thing? Well, imagine I put a 0 here, and I put a 0 here, and I put a 0 here. Then that would mean I would multiply this times this times this, and y would equal that times that times that. And that goes at the end. All right, so that times that would be, let's see, 28 times 3, 24 60, 8 times 3 is 24, 84, 2 negatives cancel, so positive 84. Now, is there any part of that that you didn't get? Like, do you get how I got this lead term? I just multiplied this times this times this. Do you got how I got the end of the equation? Which is also known as the x-intercept, because it's, it's the y-intercept, because x was 0. So that last number there is the y-intercept. Right there. Okay. And so if I was going to graph this thing, I'd need this degree, which comes from right here. And then I'd need the leading coefficient, which is the number in the very front. And if there is no number, it's a 1. If that number's positive, that means it goes up on the right. Man, so many little things to know. And there's 3 roots. -3 makes this whole thing 0. 4 makes this whole thing 0. And 7 makes this whole thing 0. So that, and that are called the zeros. They're also known as the x-intercepts. Here's -3. The 4 is like here. And the 7 is like over here. And now, if this thing ends going up on the right because this is positive, now you look at this and it's odd, so that means it's going down on the left. And my final answer looks like there's no bounces because there's no like things that are squared. And that's how my final answer looks. And I know that this curve that I made is just kind of wherever I feel like putting it, and you can do the same thing. What I'd be grading here is, did you touch it at 7 and 4 and -3, because those are the 3 things that make it 0. I'd be checking that it went up on the right because the lead term was positive. And I'd be checking that you went through positive 84. Does that look like 84? Well, I don't know. I can label it anything I want. So I just put 84 there. Now I have one more thing to teach you, and this has been like the fastest 5 minutes of math that you've done in probably 8 days. I know. We'll review all of it in a second, but I have one last thing to say. Would you agree that as this thing seems to be going up on the right, that there seems to be no limit on it? It just is going to keep going up. Then that means its limit heads to infinity. So this is the first day where I get to teach you what's called a limit. So here's how you write a limit for this. The limit of this function And it has two parts. It has x goes to, and this answer at the end is what y goes to. You don't even have to say y because its function f of x means y. So this is where the x goes, and this is where the y goes. If you haven't already, write this down. When you go to calculus, which is what comes after precalc, it's calc. And so most of you probably next year are going to take calculus. Some of you are going to choose to take the AP version of calculus, which will be moving way faster than this class moves. If you want it to be about similar pace to this class, just take regular calculus, which is considered high school calculus. But anyway, these limits are all over the place. You're going to have to do them like a million times, and this is your first limit. So write this down. All right, so would you agree, I just said a second ago that the limit of this thing is it's not going to have a limit. It's going to keep going up, 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 up. Doesn't that feel like infinity? All right, then infinity is your answer, but let's make sure that you get. If I went forever up, I would be at positive infinity, comma positive infinity. Do you get, you could go forever in the x direction and forever in the y direction? That's like going way over here and then going way up there. It would go to that. So look. The x and the y are both infinity. So there is my limit statement. Now technically, I just want to be really technical right now. This is supposed to be all underneath the word lim. It's not supposed to stray past the word lim. If some of you take the AP test, they're really fussy about that. This is all got to be one little block. Limit as x approaches infinity of the function is infinity. And now this is the first year where I was told this, but the AP test would take off like a, I don't know what their smallest amount is, but if you said equals infinity, do you get you can't actually be at infinity? You can get closer and closer to infinity though. So you're supposed to not have an equal sign there, you're supposed to have an arrow there. All right, so now let me give you another one. Everybody just make a little sketch here. And we're just going to go like that. Just make a quick sketch that kind of is up on the left and down on the right. If you wanted to describe this, you could describe it as going towards x is positive infinity, but what would y be in this case? I think some of you know. Just say it. Oh, too early after break. Negative infinity. It's going down. Okay. This spot here is like where you're going way to the left, so it's like negative infinity, and way up, so it's like infinity. Now again, this is not really a point. Do you get there is no point? It's just we're going in these directions. So then I can write the limit for this side. Limit of the function as x approaches, what's my x? It's infinity. Then the y approaches negative infinity. That's the limit statement for this function. Limits are on your next test. We would say, write the limit for this function. Do you get that's the x, which is right there? Do you get this is the y? It's like where it's headed in the y direction. That's there. This is the y part. The rest of it is just saying limit of the function. All right. Now, if you really understood that, you should be able to write the limit for this end of the function. Start with lim and f of x. You will do that every single time. You always write lim of the function. And then underneath the lim, you always write, what have I written every single time? Underneath the lim. Still too early to participate. X goes to, and the official word for that is approaches. See if you can write the rest of it. There just needs to be something here, and then something here. We're doing this right here. All right, I gotta break you out of this like not talking thing. You don't have to talk to me, but there's a kid right next to you. I want you two guys to compare. I want you two guys to compare. You guys are a little group of 3 back there. See if you got the limit written correctly. And you guys straight across, play with people behind you. George, Greta behind you. So in this case, what is x approaching? Negative infinity. Negative infinity. And then what's the y approaches? Because remember, the y stuff's over here on the right. The y is approaching infinity. And there you go. Limit of the function. As x approaches negative infinity, it's infinity. Okay, so that's how to write a limit. Now, let's see if you can put it all together. Everybody get out the worksheet that's assigned, and I just did problem 1 for you. I'd take a second and just copy that down. And then I'd like you to start doing this. You're probably gonna get stuck, and that's okay. We'll talk about it in a second. But I'd like you to do problem 1 since I just did it with you while it's fresh in your mind. They didn't ask you to write the limit. That comes later in the homework. I just wanted to show you how to write the limit. Because already here at 18 minutes into class, I've taught you everything that you need to know. And that's like seriously about half your next test. This is a ton of stuff. So when you get stuck in here, I'm going to highlight something that'll remind you. I got the leading coefficient and the degree by multiplying all of this stuff out. The stuff that's red highlighted. I figured out the beginning of my equation. The y-intercept is where x equals something, and the x-intercept is where y equals something. And a lot of times on x-intercepts, there's 2 or 3. Y-intercept, there's only 1, ever. There can only be 1 y-intercept, otherwise it won't pass the vertical line test. All right, then sketch it like I did. This time it's negative in the front, which tells you the end of the story. You know that way on the right, it must be going down. All right, so do number 1, then start number 2, and if you get stuck, I'm gonna kick in the lesson again here in about 4 or 5 minutes once you're partway done with your second problem. Okay, so the first one you were just copying me, but on this one, I'm going to call on a few people, and hopefully, if you can't do it, I'll help you. Dice of Destiny in full effect. It is row 3. Person 2, Tully, that's you. When you multiply all those highlighted things out, you get what's called the leading term. And that'll tell me the leading coefficient. So that, you multiply them all out, what do you get?
Is it -2?
X to the
3rd.
Yes, perfect. So the leading coefficient of that is -2. Very good. And since it's negative, that tells me that it's going down on the right. Okay, nice work so far. Now it's row 6, last person, Greta. What degree is this? Third degree, and that tells us something. What does it tell us about the graph?
That the right side goes
We already knew the right side.
down,
We already knew the right side went down.
middle side goes up.
Yes, because the odd number here tells us that it needs to be different than the other side. So you are correct, up on the left. So nothing really tells us the left side. All this tells us is that they will be opposite of each other. You know what I mean? We only get the right side from this lead number right here. That tells us the right side. This just tells us if it's the same or different on the left. So since that's odd, it has to be different on the left, so then it must be going up. Okay, next thing is the y-intercept. Row 2, person 2, Addie, that's you. How do you figure out the y-intercept?
We multiply the 1 with the negative 1.
Yep. The y-intercept is where x equals 0. So you put a 0 here, and here, and here. And you end up with, don't forget the negative, negative 1 times, these are all parentheses times each other, negative 2 times negative 5. Well, 1 times 2 times 5 is easy. That's 10. But then you got to go back and remember there's 3 negatives. 1 times 2 times 5 is 10. But there's 3 negatives, so it's negative 10. So that means that the middle we never even care about. It's just the end we need to know of our equation is negative 10 because that tells us the y-intercept. This right here tells us the end of the equation. And that means the y-intercept must be down here at negative 10. Now my graph is starting to come together. I know it goes down on the right. I know it goes through this spot. And I know it goes up on the left. Okay, now the x-intercept, where y is 0. Row 3. Person 2, Tully, it really likes you today. Can you tell me how to do this y-intercept? Sorry, x-intercept.
Just set them equal to 0.
Set y equal to 0. For the x-intercept, you set y equal to 0. Well, where's the y? Well, it's over here. Just a second, my iPad froze up. There we go. The y right here, that equals 0. So that means there's 3 things that would make it equal 0. So tell you what's one of them.
Negative 1.
Good. So right here, I put a negative 1, and it's going to touch there. And then what's the next one?
2.
Correct. So it's going to put a 2 here, and it's going to touch there. And this one's weirder. Please don't say 5. Because if you put a 5 there, it'll be 2 times 5 is 10, and 10 minus 5, that's not 0. So I'd write this out. I'm just bringing it down. 2x minus 5 needs to equal 0. Add 5 to both sides. 2x equals 5. X equals 5 halves. All right. So 5 halves is the same as 2.5. So the third dot is just really close to the 2 here. 2.5. Now, I think the hardest part is doing the last squiggly line. I don't feel like it's that hard, but like you got to know how to start it and how to end it and how to go through the negative 10. It has to be up on this end. So I'm going to kind of line it up so that I can go through that, through this, through this. When does it ever bounce? If there's something squared. There was nothing squared. If there was like a little squared right here, then it would mean it bounced there. But there was not a squared, so there isn't any bouncing. So they just go straight through each spot. And I was drawing it, and I'm going to continue. And then I need to go through this and go down there. There's my answer. That's not easy. Kind of harsh to come back after a nice long weekend. teachers weren't allowed to sign you anything, so hopefully you didn't get too much homework. And then I'll just remind you how this limit would have worked. If, this isn't a limit question, but if it was, you'd write the limit of the function. Please just follow along with me. I know you're not good at these yet, but the lim of the function. And then you think about, where is this thing headed? Isn't it going forever to the right and the forever down? So the x is going to infinity, and the y is going to, remember, the y is the up-down. It's going to negative infinity. Look, it's going down. That's why it's negative infinity. All right. It's really hard to read, you guys, because I get it. You're just all like barely awake and surviving school again. But I got to get a feeling for this. 5 means I think I understand everything you've taught me. 1 means I'm completely lost. Tell me where you're at. 5 to 1. All right, 4s and 5s. All right, that's awesome. Okay, so let's do this one together because it's got only one little twist. That squared right there. And it does change a couple things. You remember when I highlighted what to multiply out? I highlighted the first parts of each thing. And I never highlighted a power before because there never was a power. But that x is going to get squared. Just that and that together make the lead coefficient, which I'm going to have you write out the lead term. It makes it 2x times x, but that's squared. So does that make 2x squared? No, you're correct. It's 2x to the third. Because just that part is x squared, and then you add another x in there. So the lead coefficient is the 2. The degree is the 3. Then there's a bunch of terms that we don't care about. And then there's the y-intercept, which is where x equals 0. So you stick a 0 here and here. And then you're going to get 2 times 0 is 0, plus 7 is 7. 7 times, but wait, the negative 2 is getting squared. Negative 2 squared is 4. 4 times 7 is 28. There's a 28 at the end. So that means it touches up here at 28. Okay, and that covers the last of the weird exceptions. The rest of it's all the same. Since that's positive, it's going to be going up on the right. The things that make this 0, you like go in here and you solve inside these and try to figure out what makes the first parentheses equal 0 and what makes the second part of the equation equal 0. And then you'll get your x-intercepts. Again, the x-intercepts come from here and here, whatever makes these 0. And that tells you where they touch. And then this one's got a bounce right here. It bounces at 2. 2 is the 0. 2 is the thing that makes the equation 0, but it bounces there. I like to put a B underneath the 2 just to remind myself it bounces there. And then if it's going up on the right, which it is because it's positive, if it's going up here and it has to bounce off of that, it goes up like that. And I know that's probably pretty much it. It must be going down on the left, and it is because it's odd. I just don't know where that spot is, but if I solve this, I would. Okay, now, to keep your assignment reasonable, really hard to do that. You just should do one more like this for practice. I know they take a bit, but definitely do that top one here. And then these, we do not need to do a whole bunch of limit statements, in my opinion. I would make the quick sketch and just do these 2. So that means cross off those. For these, you can make a quick sketch of it and go, okay, I know it's going this way or that way or whatever. and then make your limit. But always do it on both ends. This is the wrong graph right here. I just did like an example sketch. You sketch it yourself. Do it right, and then write your limit. I'm going to give you an example limit. That's an example. It's just not right. That's not the right answer for that question. Okay, now you got time to ask me questions, so you can probably finish this puppy if you work in class and come up and ask me if you get stuck. And that's all I have for the video for today.